Hi class, today we're going to cover chapter 9. Chapter 9 is talking about sorting and searching arrays. Last chapter we talked about arrays, and the next thing about arrays is it could save a lot of data in there, and the next important thing is you will be able to control the data by searching it and sorting it. Like in Excel, those functions already available for you to use right away. And when you go shopping online, there's a filter, there's a searching, there's sorting for you. This all come from the basic. All those searching and sorting functions is very important for any type of programming languages. Why Google is most popular one in the last almost 20 years, because the algorithm of searching and sorting of their database. Now we are talking about billions of the data being searched and sorting at one time at a very short period of times. And so any language you're going to learn searching and sorting will be a big chapters for it. For this class, the purpose of this is for you to have a basic idea of it. In our next class, you're going to start learning how to write it correctly. Okay? So we're going to introduce few of the small ones, few of the most popular ones used. They are not necessarily most efficient one, but they are well used. Okay? First one we're going to look at is called bubble sort. Bubble sort sorting is kind of easy. You try to either you make ascending sort or descending sort. The number from smallest to largest, or the other way around. But the algorithm of searching and sorting writing is the same. Just depends how you set up. Goes up or goes down. Okay? Bubble sort is pretty easy. They control two elements at one time. If today our example is a ascending sort, what it does is they can compare the first two. If they're already in the right order, don't do anything to it, and then move on to the next one. So that means you're gonna keep the first sorting is the first L0, sub-0, and sub-1, right? When you do the next one, you just shift one. So the first still inside the sorting, the one coming is the second one. So every time you only move one element. So one of them will be repeated, but just the position different. So every time you compare two, let's say if we do ascending sort, every time you compare first one and second one, if they are in the right order, small, large, that's fine. Move on. If the second one is large and small, what you need to do, you just need to swap them. Okay, so take care of two elements at one time. Continue going to the end, and then all those from beginning to the end is called one intervals. When one interval finished, your computer check if between this interval any swap. We call it swap this between this element is the action called swap. If in this interval from beginning to end there's a swap action happened, and then you have to redo the whole thing again. Okay, you will continue to do it again until from the beginning to the end you don't have any swap happen. So what does that mean? You already have everything in order, right? In that case, the program finish, the sorting finish. That's the basic idea of the bubble sort. Okay, so you can see it here. So here they have a swap function here. Okay, they have a swap function here. Okay, so they have this continuously for loop. Okay, so this is something you can take into the codings, and you can practice the example on the book for the bubble sorts. All right, I pretty much explained it. They have a loop to continue from beginning to the ends. All right. Selection sort is a little bit different in bubble sort. Bubble sort, remember, they start from beginning, two elements at a time, and they go through the whole loop. Selection sort is different. Depends on you do ascending or descending. Okay, selection sort does, they find the number you are looking for and swap them to the right position. For example, I have a loop, in different orders. If I want to do ascending orders, what I do is from the first element, compare the beginning to the end. I found the lowest number first. Let's say if the lowest number in the position 5, what happened is I will swap the 5 to the first positions. So I will put the lowest on the first position already, and then when next interval come, what happened? I don't need to look at the first one. Start from the second element and then looking for lowest again. So selection sort it does is locate exactly what the data you're looking for, the lowest, put it in the head, put it in the right element to save it, and then move on to the next. So they are different. Bubble sort you just continuously go through the loop over and over again. Selection sort they actually select exactly which one, put it in the right position, and forget about it. Move on to the next element, find the lowest one again, put in the element 2, and move on and move on. So that's a selection sort. All right. So selection sort itself, you scan it. There's a little flow chart here. You scan it through it. Okay. If the array is still more than 2, and then you need to start scan, find a minimum number, and find a position and swap them. Okay, so this whole idea is for the flow charts. So the idea is you find the right data, put it in the right position. That's selection sorts. Okay. All right. In section sort, the algorithm for the first 2 elements which become the sorted part of the element. So what does that mean? You have a 2 element, you make it in the right order. Okay. So what happens from the rest? So you have these 2 as locations. You know, it's in the right order. When the next one coming, you know, if they are less than the first one, greater than first one, less than the second one, or the greater than second one. You know, you have the comparison already. You have the first one and second one in place. Whatever comes in, you can insert them into the right locations. Okay, that's the pretty straightforward understand it in section sort. And later on, if you're doing more programming, we're going to talk about efficientness of the algorithms. For example, in section sort, it's more efficient than bubble sort. I think bubble sort are one of the least efficient ones among all the algorithms. Okay, in section sort. So same thing, you have 2 elements, and you just know which position to put the next one to go in. Okay, so that's in section sort. The swap modules, you know, swap usually comes with a lot of library for you to use already, you know, but you can write one yourself very easily. You say you have a 2 number, you need swap. First thing is A number saved to a temporary. So now B number can override the A, and now the temporary can override back to the B. So by the end, A to the B, B to the A. Okay, swap module. And once we talk about sorting, next one we're gonna talk about search. Search, of course, you can do linear search. That will be the easiest way to code it. You start from first one all the way to the end, see if you find it or not. If you don't find it, you don't find it. Okay, but that's very inefficient because, for example, if today you have 2 million data sets, if the data happen to be at the very last one or not even exist, that means you need to go through the 2 million intervals to get there. That's very inefficient. That's why the other thing, you know, Google's algorithm are outbid everybody because they have very short. Of course, the algorithm we're talking about for searching engine is much more complex than this, but you know, that's the idea. Today we're going to mention about binary search. That's one of the considered super efficient ones. The only thing is this searching algorithm have the pre-requirements for your data. The data must be sorted. Doesn't matter ascending or descending. It just has to be sorted before you can do the binary search. Okay. So the binary search algorithm locate the item on the array by repeatedly divide the array in half. So what it does is you have an array of the 101s. Okay. So what it does is if you look at if they are sorted, ascending sort, if you look at target number, what we do is we compare the target to the median numbers. So which we have 101, that means the 51 is the median one. We compare, remember they are sorted. So if you have that, comparison, the number on the left side of the middle will be smaller, on the right will be greater. So if you compare the target number to the median number, so what happens? If the number you are looking for is greater than median, that means whatever on the left, they are all too small. You don't even need to look at them, right? You need to look at the right side of the median number. So what that means, you can cut the data, half of them, just erase them. So that's the beauty of binary search. Every time you compare to remaining data, the median numbers, and then you cut the data set you are looking for to half. So you can see if it's the 2 million data set, every time you cut, first time you cut in half, 1 million is gone, you have 1 million left. Second time you cut, 500,000 is gone, you only have 500,000 left. So compare that to the linear search, it's much more efficient. Okay. So quickly, required array is first sorted, and first comparison is done with the middle element of the array to see if it's greater than or less than the number that has been searched. If it's greater than, the number must be in the first half. Okay. If it's less than, I mean the middle one is less than the target number, it will be on the right half, second half. So it's going to continuously cut it everything to the half. Alright, this is a binary search, more or less look like. So that's the idea for you. Okay, you need to find a median number by the first plus the last divided by 2. So we find the medians. Okay, so that's a coding in the book for you to get an idea of it. And the binary search algorithm is one of the efficient ones in the comparisons. But the thing is, it has to be pre-sorted of your data. Okay, so that's the most common one we use for the sorting and search. Okay, if you have any question, let me know. See you soon.